All right, today now you're going to have to learn how to read and interpret a graph, and it's key to know what kind of a graph you're looking at. If you are looking at a position graph, that's the easiest kind of graph to look at. This is the position of something, of a particle that's moving. The time is measured along the x-axis, so you can label that as time. At time 0, what's the position of this graph? -1, okay? At time 0, the graph is at position -1. That typically means it is following a number line, and it is sitting at position -1 on the number line. So the graph is not one-dimensional, but the path that the object is traveling is one-dimensional. Okay, so it's just moving side to side along a number line. It's not moving necessarily up or down. All right, the way we read these graphs is largely in relative to positive or negative. And you break things up into intervals. And so you would make graphs like this. We'll have templates that we'll fill in. And we want to measure, is it positive or negative? So if I'm looking at the first time interval, which takes me from -3 to -2, those values are all above the x-axis, and so they are all positive. I don't need to know exactly what decimal values those are. I just need to know that it is largely positive, okay? The next section going from -2 to 3 is still above the x-axis, and so it has positive position. So we're just talking about, is it above or below the x-axis? Once I cross over -1, now I'm in a different quadrant. I'm below the x-axis, and so that would be negative position. I continue negative position. I stay at negative position until I reach the number 3. So these are all negative positions. Then I switch, and the whole rest of the graph is all positive position because it's all above the x-axis. So this is plus, plus, and plus. Now, if I want you to read the velocity from this position graph, what word could you replace in that question in terms of looking at a graph? Speed. Not speed. Nope. Okay, I say read the velocity from this graph. What are some of the synonyms we have for velocity? Okay, so speed is not a synonym. Speed is not the same thing. They are related. They are not the same. What is the same as velocity? Now you're thinking speed again. What does velocity mean? Derivative. What does derivative mean? Slope. So if I'm asking you, read me the velocity of this graph, you'll be reading me the slope of the graph. How many different slopes do you see?
3.
1, 2.
4. No, 3.
Well, there's 6 sections.
There's 3 to 4.
Okay,
5.
how many different slopes are there? Okay, yeah, there are 6 different sections. Some of them have the same value as another. So we're going to have 6 different sections with a couple duplicate values of my velocity. All right.
I don't know.
So here we go. Now, let's talk about what velocity is going to look like. So yes, if I'm looking at this first section, let me do it in. If I'm looking at this first square right here, okay, that first time interval, it has what kind of velocity or what kind of slope or what kind of derivative? 1. Okay, it has slope of 1. All right, then I look at the next, so I record that on my velocity list. It has slope of 1. Then I look at the next section, maybe this whole section all right here. That whole section all has slope, aka derivative, aka velocity. That all has slope of -1. So I record that on my slope here. Because it has negative velocity, what direction is it going? Either down, or it could be going left, or it could be going backwards. But those are all things that have negative association. So this would either be down or left or backwards, depending on, we don't know the context of this question, but it would be that whole section here. So it's going to start out going to the right or up or forwards, depending on the context of the question. Then it will switch to going down, left, or backwards. Then I have this interesting little section right here. So what is the slope right there? 0. So what's the derivative right there?
0.
So what's the velocity right there?
0.
What does that mean?
It's not moving.
It's not moving. So when something is 0 velocity, what do we call that? If it's not moving, what is it at? At rest. And so we now have our spot where we are at, change, rest. Then I switch again to a different slope. And I have a slope here. And the slope is 2, which means the derivative is 2, which means the velocity is 2, which means I'm going to the right or up this whole section or forwards, depending on the context. So I'll be going in this whole section, right, up, or forwards again. Then I will have another period of rest right here. Okay, so another period of rest. And then I'll finish up with a period of going with a -1 velocity. So again, I'll finish up with going that section down or left or backwards. You can use this to make up a story. Okay. Person rode their bike and they were going uphill for a while. They were going uphill for the time -3 to -2. That doesn't necessarily mean seconds. It could be minutes. It could be hours. Okay, so they were going uphill for a little bit. Then they were going downhill for a period of time. Then they stopped and took a little rest. Then they went uphill again for a little bit. And they took another little rest because they were tired, and then they went downhill the rest of the way. You could make a story. Or if you were talking about somebody going left and right or back and forth to school, they drove to school, they were resting for a little bit in the class, they realized they forgot their lunch at home, so they had to drive back home. They quick grabbed their lunch, then they drove back to school. Then they sat at rest for a little bit in another class. Okay, you could make up a story that could go along with the directions that this person was doing. All right, speed. Speed would mean that everything about the graph was converted to positive, okay? Everything about the graph is converted to, the slopes are all converted to positive. So everything that would have a negative slope would be converted to a positive slope instead. So that would be interesting, but that's easier to do when you're looking at a velocity graph and not looking at a derivative, at a position graph. So I'm gonna move on and show you the next one. Now, things get harder when you're looking at a graph and they say this is a graph of the velocity. And this is most common. You'll be most often asked to look at a graph of the velocity. So if the graph is the velocity, then what would the slope of the graph be that you're looking at? So you got to change your mind and you say, okay, if the graph is velocity, what does its slope represent? Well, the slope represents the derivative, and the derivative in this case is acceleration, and so I would be representing the acceleration on that part. And so this is what you would do. You would just kind of go piece by piece, like section by section. Just look at one square at a time. That square lives below the x-axis. So you would give that a negative value because it lives below the x-axis. It also has what kind of slope? Okay, and just even negative is all I need. The combination of a velocity and an acceleration that have the same sign means that this body is experiencing some kind of sensation, some kind of feeling of what's happening. And because these two things match same sign, we are feeling the sensation of speeding up. Okay, please hear me in English. It's an unfortunate thing about English. Speed and speeding up are not the same thing. Okay, speeding up is examining the combination of what the velocity and the acceleration are both doing. All right, then we're going to move on to the next segment, the next unit of time, this next block. It is still positioned below the x-axis, but the difference is that it has a different kind of slope. So it's positioned below the x-axis, but has a different kind of slope, and the slope is now positive. So the combination of that experience with a negative velocity combined with positive acceleration would mean I'm now experiencing what kind of sensation? Slowing down. Okay, the next segment. What is this? Yeah.
But why is it velocity? Or sorry, why is it negative?
Why is what negative?
V of t. Why?
Because this is the graph of v of t, and any place on this graph that's below the x-axis would be, this is the graph of v of t, and I'm under the x-axis. We could do all of them. We could do from -1 to 0. We could just do them all. Now I'm above the x-axis. You just want to go all the way across, Zach?
I think I get it.
Well, instead of looking segment by segment, let's just do all the velocities. We could do that. Okay, so what would 0 to 1 be for velocity? Okay, what would 1 to 2 be for velocity? What would 2 to 3 be for velocity? What would 3 to 4 be for velocity? Negative. And 4 to 5? And 5 to 6? And 6 to 7. Okay, so maybe that. Just do them all?
Yeah.
Okay. All right, well, let's go back to the third, the yellow box that we've got going on. So Zach, since you're in there, then this one right here that I'm looking at, now what kind of slope does it have? Okay, so then it's a double positive. It is both above the x-axis and it has positive slope. So is the next one right next to it. It is above the x-axis with positive slope. So that's a double positive. And so in this whole section, it is also speeding up. Now the next section gets really interesting. Okay, so I'll go to here. All right, now let's do what's happening right here. What kind of slope does that have? 0. What did it mean? 0 is important. What does it mean if you have 0 position? No, what does it mean if you have 0 position? Okay, that doesn't mean you haven't moved. You might have moved up to that point. Where are you if you have 0 position? You're on the origin, which could mean the ground. Okay, usually sea level or the ground. That's usually what 0 means. Or if you're on a number line, where are you? If you have 0 position, you're on the origin. Okay, so you're either on the origin or on the ground. What if you have 0 velocity? You're at rest. That means you're not moving. Does it mean you have 0 position? No, your position could be standing on a diving board. You could be, on the top of Mount Kilimanjaro. Okay, but if you have 0 velocity, you are at rest. What does it mean if you have 0 acceleration?
You have constant velocity.
What does that mean? What do you have 0 acceleration?
Constant velocity.
What does that mean? What are you doing if you have constant velocity? If you're just chugging along at constant velocity?
Not moving at a set rate.
We call that coasting.
Coasting.
Okay, you are coasting. It's like, I am just coasting along. I'm not slowing down. I'm not speeding up. I am just consistently at. So 0 is important to know. What does 0 mean in each of the relative things? 0 in position means you're on the ground. 0 in velocity means you're at rest. 0 in acceleration means you're coasting at a constant speed. Okay, those are important things so that you can, what does it mean your object is doing? You'll have to answer that in a question. All right, then our next, so this is coasting if you want to add that. So it doesn't mean speeding up, it doesn't mean slowing down, it means coasting. Then we get to our next segment here. Oops, change color. Okay, this one right here. I am still above the x-axis, but I have now a negative slope. So that's the combination of a negative and a positive, which would be a slowing down feeling. My next unit of time now is below the x-axis, so I have negative for my velocity. I also have negative for my acceleration. So there's another time that I am speeding up. That is a common question too on the multiple choice. They could give you this graph to look at, and they could say, how many intervals of time are you speeding up? So you have to count how many different times you have a combination where both share the same sign. We have another coasting opportunity, and we'll be coasting from time 4 to 5. That'll be a time of coasting. And then we have a steady time where I have negative velocity below the x-axis, but a positive slope. And that happens twice back to back. And so I'll have a plus and a plus, which means I'm slowing down. So there are 3 different time intervals, and you can answer. When you combine 2 time intervals, you are welcome to just combine them. You don't have to list them separately. You can say from -1 all the way to +1 because it's 2 right next to each other, and you can combine them that way. For some of you, you've done this in physics, so this is familiar to you. So for some of you, this is the very first time you've ever even thought about looking at a graph this way. So be patient with yourself. It might take you a little bit for your brain to catch up on this new way of reading a graph. Okay, now you should be able to take a graph that has pluses and minuses and zeros, which I've now transferred over here for you, and answer some questions. You should be able to look at that and answer the question of when the particle changed direction. A change in direction can be translated a change in velocity. Okay, a change in direction can be a change in velocity. And so when you're only looking at the velocity numbers, which would be, thanks Austin. Okay, only looking at velocity numbers, how many times do we see a change in velocity? I see 2. Where do you think it changes velocity first?
-1 to 0.
Okay, from not -1 to 0, just at -1. Okay, is the number -1 included on this chart actually?
No.
Okay, I have less than -1 and I have positive or greater than -1. I have less than -1, I have greater than -1. I don't have -1 exactly, but what I presume is happening at -1, so right here in the middle, I assume that it's changing direction. So right there, change direction. Because it was a change from negative to positive. So at t equals -1, the velocity changes sign. Where else does the velocity change sign?
T equals 3.
T equals, yep. And at t equals 3 also. I should have written a better question. Better question should be not just when does the particle change direction, but it should be when does the particle change direction and why. And so it's not going to be enough for you to just tell me -1 and 3. You're going to have to say -1 and 3 because the velocity is demonstrating a change in sign at those values. When is the particle going to the right? When is it going to the left? When is the particle stopped? And then maybe we can answer and why. Does anybody want to take a stab at that? When is the particle going to the right? And I'll And why?
Because it's all positive.
Okay, don't say it.
The velocity is all positive.
Okay, great. From -1 up until +3. And so we would say, right during -1 for time to +3, because the velocity is positive. All right, anybody want to tackle left? When is the particle going to the left? I'll get you started. Left during, tell me when. Not everywhere else. Not all real numbers. Okay? Yeah, Weston.
Between 3 and 7.
From 3 and 7. Anywhere else?
And between -3 and -4.
Yeah. From -3 to -1, and again from +3 to +7, because velocity is negative. Do you recall anything we talked about last chapter that talked about something being positive and something being negative, and that being kind of important? It was a theorem we talked about. Anybody remember what that is? How much we forget in 1 week? Weston? The IVT. Okay, the intermediate value theorem says, what's the requirement of the intermediate value theorem? It'd be continuous. So one thing we would need to know is we would need to have been told that this was a continuous situation. If we were told this is a continuous situation, then we have the IVT. The IVT says if you have sections that are positive and sections that are negative, what also must exist? You must have places where there are 0. If you have section that is positive, changing to a section that is negative, for an instant, a moment, you must be achieving a value of 0. The same thing would be if you're going from negative to positive. That is the IVT. So that gives us the answer to the question of being stopped. When is the particle stopped? In other words, when is the particle at rest? Must the particle ever be at rest? What does being at rest mean? 0 what? All right, is there a 0 velocity anywhere in my velocity chart for velocity? Is there 0 for acceleration? Yes. Is there 0 for velocity? Just because there isn't a 0 for velocity doesn't mean that it's not there. Okay, because what numbers aren't included on my chart? What numbers aren't included? There's a whole bunch of them.
-3,
-2, -3 is not included, -2 is not included, -1 is not included, positive, all the integers are not included on my chart. But what must be happening? If I am changing from negative to positive from one interval to the next, what's the only possible option of what must be happening at -1? It must be 0. The value has to be 0. The IVT guarantees that it's 0. If you change from a negative value in velocity to a positive value in velocity, there is no way to avoid being 0 value of velocity. The only place it could be 0 is at -1. So yes, it must be at rest. Where else must it be at rest that you could argue without a doubt that it must be at rest? At 3. It must be at rest at 3 as well, because there is no possible way to avoid 0. Cannot avoid it. If I'm going to be in this classroom and then outside this classroom, the only thing I can do, given my physical limitations, is walk through that door. I cannot avoid going through that door. If I'm going to go from inside to outside, if I'm going to go from positive to negative, I cannot avoid 0. So there must be rest moments here. And so the moment would be at rest where it stopped, which is another word for at rest, at t equals -1 and 3, because the IVT guarantees it. The IVT guarantees the existence of 0. If we do not know this is continuous, the IVT guarantees nothing. So we must be told somewhere that the function itself this is a continuous situation. All right, we've already answered the question about speeding up, slowing down, and coasting. We've already seen that. Okay, so we kind of circled through the times that it's speeding up, but let's just get those officially on here. Okay, Gracie, give me some times that it's speeding up. Give me an interval. -3 to -2. What?
-1 to 1.
Okay, -1 to 1.
3 to 4.
3 to 4.
And that's it.
And that's it. And why did you pick those?
Because they all have the same.
Okay.
Velocity and acceleration have the same.
The velocity and acceleration share the same sign. They're either both positive or they're both negative. All right, so then we have slowing down. Casey, you want to give me those? -2 to -1. Okay. Okay. Yeah, she said 5 to 6 and 6 to 7. I can say 5 to 7 is just fine. Okay, slowing down in that. And then when is it coasting? Taylor, you want to try that?
From 1 to 2, 3, 4, 5.
Okay, good. Why? Good job. Good job. Because the acceleration is 0. So if we answer why, because acceleration is 0. Okay, great. All right, I want you to try this with a partner. Giving you a new graph. This is a graph of the velocity again. Okay, so I would like you and a partner to fill in the plus, the minus, and the 0 for the following graph. You can pick the person near to you, behind you, whatever you want. But go ahead and try this yourself.
Everything till 7 seconds for velocity is positive. I know, it sounds frustrating. Plus that.
First. All right, Autumn, your group in the back. When do you believe the particle changes direction? And then I'm going to add and why.
The particle changes direction at t equals 7 and t equals 9 because the velocity changes signs.
Awesome. All right, excellent. She referenced velocity. Instead of referencing it or the graph, she specified what she was talking about. Particle changes direction at those 2 times. Okay, great. Austin, how about particle going up from your group back there?
Me?
Yes. I don't know.
Sorry. 1 second. I said up is 0 to 7 and 9 to 10. Because velocity is positive.
Okay.
Down
Yep.
is 7 to 9. Because velocity is negative.
Oops. Okay.
And stop.
So just notice, like he's saying velocity is negative. I'm writing v of t is less than 0. Same thing, right? Those are both fine. You may write it in English words, or you may use math symbols. That's totally fine. Okay? All right, stopped.
Stopped is 7 and 9. Because it crosses over the.
It crosses over the origin.
Oh, sorry.
Doesn't cross the origin.
Velocity changes signs.
That doesn't mean it's stopped. You're close.
It passes 0.
You're so close.
Velocity.
You know what? He was in the bathroom. He missed it. All right, who's got it? Luke.
Because IVT, it guarantees that within the interval that if a sign changes changes to the opposite sign, that there will be a 0.
So IVT guarantees V of t will be equal 0 every time V of t changes sign. Is that okay? Am I capturing what you're saying? Okay, and how come you could use the IVT?
Because it's continuous.
The original graph was continuous. The original picture we looked at up here, okay, was continuous. So therefore we could, and so you should probably work that in since the function, the graph of velocity is continuous, the IVT does guarantee. Okay? Yeah.
Why can't we just say because it crosses the x-axis?
You're saying, so it, meaning the velocity, yeah.
Reaches 0, so
Uh-huh. Yeah, so in this case, we have a picture and we know that we have this value. So you can also use that. All right, so if you're only working off of a chart and you have nothing to look back to and you don't know what the value is, then you would need to use the IVT to infer that. Okay, great. All right, awesome. Okay, let's see. Jack, when's the particle speeding up?
It's speeding up between 0 to 2, 7 to 8, 9 to 10 because velocity and acceleration are the same.
Oops. And you said why?
Velocity and acceleration are the same.
Okay, they aren't the same, but they have the same sign. Okay, so your language would maybe just be a little bit more clear. So they aren't the same as each other, but they do have the same sign. Another word you could use is the nature, same nature. They both have positive nature or they both have negative nature. All right, thanks for that. All right, Bosco, you want to do slowing down?
Yes.
Okay.
2 to 4
Okay.
and 6 to 9.
How far? 6 to what?
9.
I don't think so, because we just said that it speeded up during 7 and 8.
Oh.
So it can't
6 to
be, okay, it could be 6 to 7. Anywhere else?
And 8 to 9.
There we go. And why?
Because they have different sign.
Because they what?
Velocity and acceleration share a different sign.
Okay. Have opposite signs. Okay, good job. Okay, great. All right. And then Josh, how about coasting?
4 to 6.
Okay,
Because acceleration is 0.
perfect. That's all we need for that. Okay. All right, any questions about this? Yes.
Oh, wait, sorry, another question about this. So-
Okay. So we've got, everything changes when you're looking at a velocity graph. The first graph we looked at was not a velocity graph. It was an original position graph, which means velocity is read differently. When you're looking at a position graph, velocity is the slope. When you're looking at a velocity graph, velocity is the values of the function and acceleration is the slope. So it all depends. You have to watch what they're telling you that you're looking at, because you could answer the whole thing wrong based on if you think you're looking at the wrong thing. All right, so be careful about that.